Hi guys and welcome to this session by Intellipaat. MSBI is a suite which comprises of tools which provide extremely efficient solutions for BI and data mining. So in today's session, we'll be looking at few different concepts related to MSBI. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Now let's talk about today's agenda. So we'll begin today's session by answering what is BI. After that, we'll have an overview on ETL, SQL, SSIS and SSRS. After that, we'll talk about what is dimensional modeling as well as ER modeling. After that, we'll wrap today's session by answering what is analytical queries and we'll have a simple introduction on reporting tools. Also guys, we do provide end-to-end training on MSBI tools, so if you are interested, you can check out the course details given in the description below. Now, let's get into the session.
When we think of business intelligence, what is the first thing that comes to our mind? So all of us here would have, in the IT world, all of you would have heard the term business intelligence. Some of our colleagues would have been working in BI. If you're completely new to BI, you will have some peers who are working in BI, or you have worked in BI. And in case if you come across a complete stranger, and if you tell that person I'm in IT and I work in a branch called BI, business intelligence, the first question that comes to their mind is, okay, but what has BI got anything to do with technology? Okay, so in short, business intelligence is using a set of tools and methodologies and softwares to implement a solution which ultimately adds value to your business, right? So if you just try to separate those two terms, business and intelligence, what it means is you are adding intelligence to the business. You're doing something, you're implementing a set of solutions, using some tools, using some methodologies to add intelligence, aka value, to your business. Ultimately, you're adding intelligence to your business. And what does adding intelligence to your business mean? Adding intelligence to your business translates into enabling your business and enabling your business leaders to make better decisions. Now that business could be your own company, that business could be your clients, that could be your customers. Think of anything. It could be a small retailer, it could be a large conglomerate, whatever it is. Ultimately, you're using BI tools, okay, these tools, these methodologies, these solutions to add value, to add intelligence, and ultimately enable the business to make better decisions. Okay, so that is what BI stands for in short. And as I mentioned initially, there are a lot of BI tools in the market today. MSBI is just one such BI tool. MSBI stands for Microsoft Business Intelligence. Similarly, there are so many other BI tools, Ab Initio, Informatica, Spotfire, Tableau. These are all BI tools, and all of these tools have one thing in common. And what is that thing? That it uses a set of methodologies to build solutions which are ultimately used to add value to your business. That's the common denominator across all these tools, that you're adding value to your business, you're adding intelligence to your business, and you're finally enabling the business leaders to take better decisions to obviously benefit their business, right? Now, just to come to the broad framework of MSBI and for that matter any BI tool, okay, and what I'm trying to highlight here basically is, and just to start off with the scenario that we're taking here, the scenario really is, and the scenario what we are taking here is ABC. ABC is a pharmaceutical company. It's a big pharmaceutical company which manufactures medicines. And what ABC does is it has retail outlets spread out across the globe. It has a lot of different retail outlets spread out across the globe, and the medicines that it manufactures basically are marketed in retail outlets across the globe. That is what it basically means. Okay. Now, 1, 2, 3, 4, 5, 6 is all the 7 boxes represent retail outlets. So I just kept 7 outlets, 7 boxes here as an example. Okay, and what I'm highlighting here is each of these boxes, okay, each of the retail outlets will have its own system to keep a track of its sales, right? These are all retail outlets. These are all outlets which sell company ABC's medicines. So obviously you will have retail outlet 1, which is a very small retailer. It's just like it's a very small shop, it's a neighborhood shop, and maybe all that they have is a small computer where they use an Excel sheet to track their sales, like daily sales. They will have the date column, what is the product that they sold, what is the medicine name that they sold, and how much money did they make in total from it. Okay, so that's company 1, that's retail outlet 1, which is storing its data in what we call an Excel file. Okay, yeah, company 2 is probably a little more advanced in its overall approach, and it has a full-fledged SQL Server solution set up. Okay, let's say it's a retail outlet it's kind of a retail outlet where you have multiple retail outlets. This is a retail chain, so to say. Okay.
Just a quick info, guys. Intellipaat does provide end-to-end training on MSBI. So if you are interested, you can check out the course details given in the description below. Now, let's get back into the session.
So it has a SQL Server setup. Company 3 has an Oracle database setup. So it stores its data, it stores its sales data in an Oracle database. Company 4 can store its sales data in a flat file format. And flat file format is nothing but a simple text format. Okay, and you can think of it something like a notepad or an editor, any kind of text editor. It just stores data in a simple text editor. Okay, and company 5, let's say, is using DB2 database. Company 6 probably has some other way of storing files in XML or some other front-end UI. Okay, so in short, what I'm trying to get at here is all these retail outlets may have their own different ways of storing this data, right? So you go to a shop, you buy some medicine, and let's say you buy some medicine from company 1, retail outlet 1, and then retail outlet 1 will store that data in an Excel file. So it will be like, okay, on this day, this customer brought this medicine and the total sales I made was this. So all these retail outlets will have different means of capturing their sales data, right? Now, what is the significance of this? Why have we been discussing this? Because the reason why we are discussing this is because company ABC is obviously the manufacturer, right? So company ABC will manufacture its medicines, and it will basically ship its medicines across, distributed medicines across to other retailers. Okay, obviously there'll be other distribution channels in between, but ultimately the end objective from company ABC's point of view is to understand how well it is doing in terms of sales. How are customers buying their medicines, right? I'm just taking an example of a medicine. ABC could be anything. ABC could be a retail chain, has its own products. So it could be anything. It could be an electronics company. It could be something like an Apple, where Apple is selling its iPods, so stuff like that, and iPhones, and you're keeping a track of how people are reacting to those iPhones from the retail outlets. Okay, so ultimately what we are driving home here is these are all individual data sources that you have. These are all individual data sources that you have from across all these retail outlets, and ultimately for company ABC to get the full picture of how it is doing in terms of sales across the whole country or across the whole world globally, it has to collect data from all these retail outlets. Okay, it needs to collect data from company 1, company 2, company 3, 4, 5, 6 across all these retail outlets, and finally get a big picture overview of where it stands in terms of total sales. Okay, so that's what we are trying to drive home here. So and to do that, it has to, you can see that it has to collate data from the Excel files. It has to get all these Excel files back. It has to get all this SQL Server data to be migrated back, Oracle data to be migrated back, flat file data to be sent back, DB2 data to be sent. Obviously, it won't be like physically people will go and ship data back, but then there's going to be like separate setups available through which it has to consolidate the data. So in short, the word that we're using is consolidation. Integration is the word that we're using. So you have data available in different formats, and for you to make any sense of this data, and for you to basically integrate this data, you have to bring it in one common format, right? You cannot do analysis from the company ABC's point of view. If you think about it, it cannot perform a holistic analysis if some of its data is living in SQL Server, some of its data is living in Oracle, some of its data is living in DB2, some of it is in Excel. It cannot perform a holistic analytics on that data, right? So for it to perform any meaningful analytics on its data is very important. It's extremely important for that data to be in one common singular format. Okay, and that singular format, it could be anything. I mean, that singular format, which we call the destination, okay, that is in company ABC servers, that singular format that it brings this data into, that could be in Excel, that could be a SQL Server, that could be an Oracle, that could be anything. Okay, but the idea is convert all these different formats into one singular destination format, so that the holistic analytics becomes much simpler, and you don't need to have skill sets. You don't need to have people who know all technologies for them to do any kind of analytics. First, you just think about it as an analogy, and if I just explain this, what I mean to say is, for you to analyze Oracle data, you need to have people who understand how to write Oracle queries, right? For you to analyze SQL Server data, you need to have people who understand how to write these SQL queries. Right? For you to analyze Excel data, it could be a Power Pivot model or whatever they've built. You need to have people who are at least familiar with DAX queries, stuff like that. Okay. So you need people with different skill sets. That's a broad idea. So that's an investment. That's a cost from the company's point of view. You have to still maintain different systems. That's not feasible, right? So which is the whole reason why we are trying to have one single denominator here. So you're trying to convert all these different disparate sources, and we call them disparate heterogeneous sources from a very BI terminology point of view, and you're trying to integrate all of that into one common destination, which is, in our examples, we're going to take it to be a SQL Server. So we're going to say for company ABC, that destination is a SQL Server database. Okay.
Just a quick info, guys. Intellipaat does provide end-to-end training on MSBI. So if you are interested, you can check out the course details given in the description below. Now, let's get back into the session.
So now company ABC has information for all the retailers, and now it becomes so much simpler to, next time when company ABC's management meet is happening, the annual meet is happening, and they need to understand how they have performed over the past 1 year. In the northern region, what all customers across what all categories, across what all genders were buying their products, how much of sales were made by males, how much of sales by females, by northern region. All these kind of analytics can be made once it has the entire data available in its servers, right? So that's the first concept I wanted to drive home, that you have disparate sources, you have a large variety of sources in different formats, heterogeneous sources. Bring all of them together, integrate them, and convert them to one single format. Okay, that's the fundamental rule of analytics. You have to bring them into one single format, and this is a process that we call ETL. Okay, this is what we call ETL. So what does the E stand for? E stands for the extract, where you're extracting data from the source. The T stands for the transformation, where you're performing some kind of transformation on your data, and finally the L stands for the loading, where you're loading the data into that common destination that we were mentioning here, which is in our case we're taking the example of a SQL Server. So I'll just repeat again. That's the term that we use, ETL. Very important concept. One of the fundamental BI concepts that you have. You're extracting data from your source. Here our source it basically points out to those 7 retail outlets. That's my source. You're extracting data from each of those 7 retail outlets. You're doing some transformations on your data. Okay, it could be some kind of basic data cleansing. I'll talk a little bit about transformations in a while, but you can just think of an example. Like it could be something as simple as, let's say, your +91 mobile numbers if you're from India, or some kind of country code that you have 0 country code. So different country codes, you prefix your mobile numbers by that country code. But then when you're loading the data, you want to cleanse that. So you want to make sure that when you want to transform your data, you want to convert your phone numbers, and you want to remove those country codes from your phone numbers. Okay, that is an example of a transformation. Okay, in short, it is just cleansing your data. Okay, it is just cleaning your data. It's just making your data proper for storage in a database. You're just standardizing your data and just formatting your data. That's what it means in short. Okay, so you're extracting your data from the source, you're performing some kind of transformations on that data, and finally you're loading the data. The L stands for the load. You're finally loading the data into company ABC's destination, that common destination, which in our case is the SQL Server. Okay, company ABC SQL Server. So that's the ETL process. So whatever happens in between here, whatever happens here is part of the ETL process. Extraction, transformation, and load. And that's basically what we are describing here also. And if you can see that I've kind of just put ETL here, so it's just again taking data from the different sources, and this is the part where you're doing the ETL, right? And to perform ETL, the tool that we use in the context of MSBI is what we call SQL Server Integration Services. That is what we call SSIS. Okay. So we use SSIS to perform ETL operations. And as you can see that I'm extracting data, I'm doing the transformations here, and finally I'm loading the data into company ABC's SQL Server database. Right? Make sense? Now, one thing you have to understand here is the fact that this SSIS is the tool that you're using. How do you do ETL? The first question that might come to your mind is, how do I perform ETL? The way you perform ETL is using SSIS. And similarly, similar to SSIS, there are other ETL tools also. Okay, as I mentioned, Ab Initio, Informatica. So this can be any tool. So ultimately, it's a tool that you're using to perform this operation, right? Yeah. The concept is ETL. ETL is what you're doing, but how do you do that ETL? How do you perform that ETL? How do you do those mappings? How do you do that data transformation? How do you extract and convert to SQL Server destination? You use SSIS, SQL Server Integration Services, for that. Okay. Now, The next phase of the puzzle really is what happens after you have loaded that data into the destination. Okay, what happens after you have loaded the data into company ABC SQL Server database? So up to this point, we are clear, right? Up to this point, we are clear that, okay, so now ABC has all its data in its own SQL servers. Now the analytics becomes so much simpler, right? Because now any kind of question that company ABC might have about its sales over the last 1 year across different regions, across different gender categories, different product categories, brackets, income brackets, all that information is now with company ABC. Okay.
Just a quick info, guys. Intellipaat does provide end-to-end training on MSBI. So if you are interested, you can check out the course details given in the description below. Now, let's get back into the session.
And it becomes so much easier to perform that analytics, right? So next time when the management, so please understand, but still the data is still residing in SQL Server, right? If you think about it from company ABC's point of view, all its data is now living in a SQL Server. The next time a company ABC's management wants to ask the question, okay, what was the trend of my sales over the past 5 years? So that data is in a SQL Server, but what do? I mean, you're in a management meeting, and what do? Do you open up the database and you query the database? Will you do that? Will you write a SQL query there? Obviously no, right? Obviously no, you will not write a SQL query. So what you have to do in that case is you need to have a reporting solution built, right? You need to have a reporting solution built which will automatically generate reports on the fly for you. Okay, and how do you build a reporting solution? And this is where we introduce the concept of SSRS, SQL Server Reporting Services. Okay, so SQL Server Reporting Services is the reporting engine through which you generate reports in MSBI. I would not really call dashboards. So people do use certain dashboards, but let's just say reports and dashboards in MSBI. All right. So that is what we call SQL Server Reporting Services, because although you have performed the ETL, although you have you've been able to store your data in the data warehouse, but then it's not really in the best of formats, right? It's not really in the best of formats for you to represent the data to top management. So you won't tell your managers that, okay, you know what, the data is in a SQL Server database, so if you want some information, go back and write a query. So you won't say that. So for us to represent the data effectively, you have got to develop reports on top of that data, so that next time when someone, you in for a meeting or anything like that, you can simply open up that report and you can just, visualize that data. Okay, so similar to SSRS, there are a lot of other reporting tools available. Just give an example of SSRS. It's the same way that I said for ETL, you can use SSIS, Informatica, Ab Initio, okay, Data Stage. There's so many ETL tools out there in the market. And similarly, for reporting solutions, SSRS, SQL Server Reporting Services, is from the MSBI suite. Similarly, you have Excel. Excel is also a very, very powerful reporting tool. So what I'm trying to drive home is that Excel can also be used to perform basic ETL. You can use Excel to perform basic ETL operations also. Obviously, we all understand Excel can be used to generate reports, but you can also use Excel to perform ETL operations. So how do you do that? So that's where the get and transform data comes in. You can actually extract data from here. You can perform transformations. You can perform complex transformations. You can power pivot. You can do a lot of cool stuff using power pivots. You can generate relationships and all that kind of stuff. Cool stuff using Excel. All right. So coming back to our example, you can connect to the server. You can actually select your database. It's very easy to connect to a SQL Server database using Excel. And just to again bring up the model here for you, just to quickly show you one simple example of an Excel report. So I have a table imported. So what I'm basically showing you here is an example data warehouse called AdventureWorks DW. So I'm going to share this link also with all of you, how to install this particular data warehouse. So this is the Microsoft supplied default data warehouse that you guys can all use for your learning purposes, for your L&D purposes. Okay, so I'm going to quickly bring that up for you. As you can see, I'm opening up my SQL Server 2014 here. The database engine, obviously the server type comes up, just connecting my database engine. My server name is dot. Dot stands for local host. That's my local system. Okay. Instead of dot, you can also use local host. I can use SQL Server or Windows authentication, and finally you have the username and password specified. Okay. So that's it. I've connected. And what you can see in my SQL Server, so this is basically I've connected to the default instance of SQL Server, and you can see that in databases I have a particular database called AdventureWorks DW 2014. Okay, so this is a Microsoft supplied data warehouse. Okay, we haven't talked about data warehouse yet, so don't get confused about what is a data warehouse right now. So just think of it as a database. You can see that it's still listed out in the databases section. Okay, you can still see that it is nothing but a database. So don't confuse between what is a data warehouse and what is a database at this time. For now, just think of it as a database. It is something that contains data. Okay, you have a set of tables, and each table is nothing but a collection of rows and columns, right? So that's what a database is. It's tables, schemas, views, primary keys, foreign keys, and all that you understand from an RDBMS point of view. That's all that a data warehouse is. Few differences in terms of modeling. In fact, a lot of differences, but I just wanted to keep things simple and not confuse you any further. But just, a data warehouse is nothing but a kind of a database. So data warehouse is a database, but then all databases are not data warehouses. So in short, again, just to repeat what I'm saying, a data warehouse is a kind of a database, but all databases may not be data warehouses. So that's why you can see data warehouse is also it's listed under database. How you can get this thing installed, how you can get DW 2014 in your system. So you can go to the CodePlex link. Microsoft has a CodePlex link available, and obviously this is not the only data warehouse you have. You have a few others to practice on. You have something called Importers DB, which Microsoft recently released. You also have Northwind. Northwind is also a very popular database and data warehouse, so you can use that as well. This is the AdventureWorks. This is where you get to find all your data warehouses. You just click on this AdventureWorks databases 2000, 2008 R2, 2014, and this is where you have 2014. So it is the new importers thing that Microsoft released, White World Importers, very recent thing that and obviously you have Northwind also here. Go to downloads for more information. For our intents and purposes, we can actually click on AdventureWorks Databases 2014, and this is where you will get to see the code for AdventureWorks 2014. You can download this and you can get this up and running in your system. Okay. So there are two ways you can do it. Provided you have SQL Server installed, you can either do it through a script. So as you can see, this is the script. Script is nothing but a .sql file. And what am I trying to say here? So whenever you write a query in SQL Server, it is generated as a .sql file. So all queries are saved as a .sql. You can see that right now I'm trying to write a query. It could be something as simple as select star from dim product. It could be something as simple as this. But then you want to save this stuff, right? You want to save this stuff. As you can see, whenever you type in SQL Server, IntelliSense is enabled. So whenever I try to select something, obviously I get a drop-down interface through which I can click on tab that's selected, and I can select from dim product. Okay, if you want to select any particular columns, you might want to come here, English product name, and again IntelliSense works. Let's say you want to select color, and you can see again these are all the functions that will come up. So IntelliSense are very niche features. Click on COL and color will automatically come up. You can see that it's a field. It's a field in a table, hence it will come up in a different icon. Click on it, and as dim select stuff from dim, you can click F5 to execute, or you can also select that particular instance and click on execute here. There's two different ways of executing the same stuff. I think this is where IntelliSense option is enabled in SQL Server Management Studio. And what we are basically using here, in case you're confused what we are even doing here, we are using something called SSMS. In short, it's called SSMS, SQL Server Management Studio, to interact with your underlying SQL Server database. Okay, so that's your client tool. That's your front end GUI, graphical user interface that you're using to interact with your backend SQL Server database that you have. So all the tables, whatever you have here, that's what you're interacting. And we have a misconception. So you might all, and not getting too much into the SQL Server concepts right now. Obviously, I'll be happy to have a separate discussion with all of you, probably later on as a separate course where we can talk more about SQL Server. But then just to quickly walk you through this, ultimately what you have in SQL Server and its databases, if you look at it, go to properties. So databases are nothing but a set of files. Okay, so just to look to the file section, you will see that there is nothing but a set of files, and one of the files is what we call the MDF and the LDF files. So all databases, all tables, so they're not really tables. They don't exist as tables. If you look at your computer system, how they're actually, how they're actually stored. So they're not really stored as tables. There's nothing called tables in looking from a computer perspective, right? So logically, it is grouped as tables. Logically, when you look at it, it is logically organized into tables. But then physically, they're nothing but files, right? They're nothing but files. So they are files which are stored in your hard disk. And if you just want to look at the path, you can right-click, go to the properties of the database, scroll right down to the right, and you can see that this is the file name that you have. So it's stored as an MDF file and an LDF file. That's how all databases are stored as. So MDF stands for the master data file, LDF stands for the log data file. And where do you find this? Usually you will find this in the C drive. You can actually navigate to the C drive, And when you go there, you should be able to find your SQL Server folder, and inside that you should be able to find the MS SQL Server. Double click on that, go to MS SQL, go to data, and this is where you should be able to find all your databases, right? So that's your log, that's all your database files that you have. Most of you may not have access. If you're using a company laptop, you may not have access to it. Usually C drive, these folders require admin privileges, but then I'm using my personal system and I have admin access to it, so hence I can access the needless to say, it is a very, very secure place, right? So obviously it won't be easy to get access to the database files. If you have that, then there's no security at all, right? So
just a quick info, guys, Intellipaat does provide end-to-end training on MSBI. So if you are interested, you can check out the course details given in the description below. Now, let's get back into the session.
This is usually a very, very high security area where not everyone can get into, okay? Because if you have access to this, you can just copy it. It's just like a file, okay? You can just copy it, paste it, copy it to a local removable media, pen drive, hard disk, whatever. And it's very easy to steal data this way. So it's highly restricted that way, okay? So what I'm trying to drive home is ultimately a set of files that you have, and all that you do in Management Studio is you try to find out a way to, if, for instance, when I query this, I see it as a table, but it's actually not a table. It's nothing but a file. Okay, so product, dim product, the underlying table is nothing but a file. It's just stored as a file in your hard disk. So Management Studio is just displaying it as a table. It's just logically grouping it as a table. That's how it's done in SQL Server. Any database management system for that matter. Okay. All right, so it's very easy to, going back to a discussion on how to get this thing set up in your system, it's very easy to either use the SQL script. And as I was saying, any query that you write here, you can actually save it as a .sql file. You can see that you can save this query as a .sql, okay? So you can either download the script. The script is nothing but a .sql file. So what you can do is you can download the script and you can run that in Management Studio. Okay, so you can just run that in Management Studio just like you running this query, and it will actually complete this whole new database for you. Okay, and the other thing you can do is you can download the backup. You can download the backup file. Okay, there are two kinds of scripts available. One is for the OLTP and one is for the warehouse. Now this is interesting. So this is the case for all AdventureWorks, for instance, Northwind, or even wide world importers, whichever three examples you choose to install. Obviously for our examples we'll be using AdventureWorks, but whichever example you choose to install, they're available in two variants. One is obviously the OLTP version, and the other is the data warehouse, the OLAP version. Okay, the OLTP version is the typical database that we understand. Okay, the typical relational database, normalized tables. That's what we understand. But for our intents and purposes, we will be using the data warehouse version, the OLAP version. Okay, we'll be talking more about that in tomorrow's session. But then, as I said, just be very mindful of the fact that you're setting up the data warehouse version in your system, which would mean either this option that you can see here, data warehouse script, or this version which says DW 2014 full database backup. The script will have the .sql file which you can directly run in Management Studio, and the data warehouse backup will basically download what we call a backup file, which is a .bak file. Okay, and how it works in databases, and again, just to conceptually talk a little bit about backup and restore, how it works is it's part of a DR measure. It's a disaster recovery measure where you basically take a backup of a database. Okay, and taking a backup of a database is nothing but saving your database files and copying them back on a different machine. So that's simply what it means. Okay, if you want to move your database from one server to another server, one location to another location as part of any other disaster recovery measures, you can simply copy the files and paste them back, restore them back in another location or another server, another SQL server, right? So that's what backup and restore basically means. Very easy to back up a database. If let's say if I'm trying to implement a DR measure here, actually right click on it, go to tasks, and you can actually back up a particular database. Very simple to do that. Point and click approach, and you can generate a .bak file like this. You can see that immediately it tells me the destination of that .bak file is stored in the disk, and it's stored in this particular location as a .bak file. And the other thing I can do is, once I have that backup, now what is the next thing I do? So now I have backed up my database. I want to restore it. Now I've already backed up from that the problem database, the problem server, and I want to restore it to my new server. I backed up from my old server. I want to restore in my new server. The way to do that is, again, very simply, just right click on your databases, go to restore database, and now what you can do is you can search for your file here. So you can click on device, and you can click on this ellipsis sign. Obviously you want to back up from the file, click on add, and now this is where you have to choose from which backup file you want to restore. So remember, in our example here, I had downloaded my .bak file. So remember that when you download this file, it will by default go to your downloads folder. Okay, but when you go by this option, by default it will always, so in short, when you click on this ellipsis sign, when you click on add, by default it will always open up in this particular place. Okay, so this is the place where it will open up. You can see the backup folder, and if you just have to navigate through the options here, the backup folder is nothing but this place. This is where we're looking at right now. Okay, so you have to ensure that you're basically copying your files from your downloads folder onto your backup folder. It's not necessary. You can store it anywhere. You can just navigate through the file system, but again, it's a little difficult. It's not exactly your typical Explorer. You can see your desktop and other things are missing. It's not pretty simple and straightforward to navigate here. It's easier. It's much easier to just go back and set it in the default location than than just break your head around where to go and stuff like that. Okay, but otherwise, you can see it's not the typical Explorer options that you get. It's basically opening up in C drives. If you understand your C drive, how to navigate, how to go to other folders from your C drive, it's good, but then you don't really have the usual folder structure of desktop, documents, stuff like that, right? So this is the default location where it's going to fetch it from. So you can just click on it. You can click on OK, and click on OK, and that's how you can restore. It's very simple overall. Okay, so you can see this is how you can restore. I'm not really going to click OK right now, but once you click on OK, this is how it's going to do. It's very simple, point and click. All right, so I hope that clarifies. How I'm setting up AdventureWorks DW, right? And that's basically where what we're discussing. And just before we broke into the example of AdventureWorks DW, I was showing you how to create simple reports using Excel. And as you can see here, I've set this up. What I can do is, if I want to analyze sales, let's say I want to analyze my total income, yearly income, based on something like a gender. It's very, very easy to do that kind of analytics. Okay, it's not the best kind of interface I have right now. You can obviously modify this charting. You can use Power View components to really improve the level of this particular graph. You can use additional components like marital status. You can use it in the legend, the CD section, and you can really generate some cool analytics out of it. You have a wide variety of formats. You can go to design. You can go to you can change your charts. You can go to format. A lot of different stuff you can do. You can change your chart types. You have a large variety of charts you can select from. Okay, and there's a lot of stuff you can do here in Excel. All right, so moving on and just coming back to our diagram here. So far we have discussed about the concept where you're storing this data in a data warehouse, in a SQL Server data warehouse. We have talked about reporting aspect where you're finally generating reports using data visualization tools like Excel, Tableau, SSRS for our course, of course, SQL Server reporting services. And the final component, the final piece of the puzzle is SSAS, the SQL Server Analysis Services. And you use SSAS to basically build what we call a cube. Okay, and the way I would like to explain this is, let's say you want to run a query. Let's say think about it. And again, one of the things I told you initially is that I want you guys to have some basic knowledge on SQL Server. You don't need to be experts, but at least you need to understand how to write basic SQL queries. So just got to come back to SQL Server Management Studio again. You have to write a simple query here. You have to do some kind of analytics. Let's say you can go to Management Studio, right click on it. You can design query in editor. If you feel you're not very comfortable in writing queries, you can always use a SQL query editor. And I'm going to take my two tables, internet sales, and let's say I'm going to use my DIM product. Click on add, and I'm going to select my sales amount here. I'm going to select my color here, and what I'm going to do here is I'm going to group by color. I'm going to calculate the sum of sales, and obviously I'm going to display the color. So click on OK. That's your query. It's a very simple group by query, and what I'm essentially doing is I'm grouping my I'm generating the total of sales and I'm grouping it by color. So for each color, what is my total sales? And obviously the underlying level I'm joining between the two tables, right? So So what I'm trying to do here is I already have this data, and think about it from this point of view that AdventureWorks is your company ABC's data warehouse. So think about it this way. That's your database that you have here. And you're running a query on this database and you're trying to generate what is your total sales across each color. Okay, because think about it, management will not really like detail level data, right? There are two kinds of information that you can get. A, you can give them the detail level data. So the other kind of query I can generate is this. So I can actually come back, copy, paste this, just put this down. Okay, you can remove the sum, you can remove the aggregate here, and you can remove the group by. So this becomes a detail level query. You can just select just select this part and click on execute, and you can see this gives you the detail level query. So for each detail level query it gives you. So you can see there's 60,398 rows are there. Now, when you're representing data to management, they're not interested in your detail level data. They're not interested in day-to-day data. They're not interested in hourly or in minute by minute information. They want to look at the holistic picture, the summarized information. In BI terms, we call it aggregated data, summarized data. Okay, and whenever we talk about aggregated data, summarized data, we introduce the concept of group by. We're looking at data which is grouped. Okay, so what we are trying to get at here again is the fact that group bys take a lot of time. So when you try to run a group by, when you're trying to aggregate your data, when you're trying to summarize your data, it takes time. Okay, so if you do some analytics on it, if the time it takes to run this query and the time it takes to run this query, this query will take more time to run. So here it's instantaneous because it's just like so less rows. 60,000 rows is very less from a SQL Server standpoint, but in short, it takes time to run this query. Group bys take time, and almost always, if you go back to this figure again, almost always when you're generating these reports, and if you go back to the Excel example that I took here, so you can actually look at this report and you can insert a chart here. Just want to insert a pivot chart here. Let's say insert a bar chart here. So what you're doing here ultimately is you're grouping, right? You can still see your grouping. You're grouping by gender. You're grouping by marital status. So ultimately, you're doing grouping. You're not displaying detail level data. So whenever you display data in bar charts, line charts, whatever charts you take, almost always, 99% of the time, you're displaying aggregated data. So think about it at the underlying level. It is still doing a group by. Think about how Excel is representing this data. Excel is not performing any kind of magical calculations. Excel has to at the underlying level, Excel is still querying the data, right? How is Excel getting this data? Ultimately, this data is still coming from the database, right? So Excel is still running that group by query on the database. That is how Excel is getting the data, and all it's doing in the bar chart is displaying that information out. So the charting part, the visualization is just displaying that information, but it's still querying that data using a group by. And that takes time. Okay, so when you think about management, when you think about representing the data to management in terms of chart suite, Excel, SSRS, whatever tool you use, you are almost always displaying aggregated data, and aggregates take time to generate, which is where the concept of SSAS comes in. So SQL Server Analysis Services generates what we call a cube. This is called an OLAP cube. Okay, OLAP stands for Online Analytical Processing. It is basically a counterpart to Online Transactional Processing, which is OLTP. I'll talk more about that tomorrow when I discuss concepts of databases and data warehouses. But we generate what we call an OLAP cube using this SSAS. And in an OLAP cube, what we do is we store these aggregates. We pre-calculate these aggregates and we store these aggregates in the cube. So for instance, something like this that we did here, we wrote a query from which we calculated what are the total sales for each color, what are the total sales for each color. So what we will do is we'll calculate these values, we calculate these totals, and we store them in the cube in predefined sections of the cube. So the next time we're generating an Excel report, for instance, we're generating an Excel report to find out what are the total sales across, what is the total income across this particular gender for this particular marital status. So it turns out you don't have to calculate this. You don't have to calculate this. This is already stored here in the cube, and all you're doing is just extracting this data from here. So you save a lot of time. So in short, just to repeat again, aggregators are pre-calculated and cached in the cube. They're already stored in that cube. Okay, so that's the basic and the broad concept of using a cube. And once you have a cube, again, you can connect to a cube using reports, right? So the same way that you can directly connect to a database using reporting services and Excel and other reporting tools, the same way when you have a cube available, you can directly connect to a cube using Excel, SSRS, and other reporting tools. Okay, it's the same concept that you have here as well. All right, and finally, all this information goes to the end users. So the real thing is, so SSAS is a very optional component. As you can see, the reports can be generated using the database as well, but then the cube is the optional component. From a very performance standpoint, if you want better performance, you want your reports to load faster, we usually implement a cube solution on top of the MSBI ETL and reporting solution we're already building. Now I'm going to give you a much more holistic understanding of what a data warehouse is, and I have listed out a few basic concepts here. So and I'm going to go through this thing as of now. You just open up my SQL Server. You will note that data warehouse is not a it's not a special thing in SQL Server. So you don't have anything specifically called data warehouses. There's nothing specifically named data warehouses in SQL Server. So everything is a database, but a data warehouse is a special kind of database. That's the reason why I say all data warehouses are databases, but all databases are not data warehouses. Okay, so ultimately a data warehouse is nothing but a part of a database. So that's a very important concept to keep in mind. So whenever you in the world of BI, you hear someone say, okay, it's a data warehouse, you're building a data warehouse. So please keep in mind that ultimately it is still a database. Okay, it is still a kind of a database. The data warehouse still lives inside a SQL Server RDBMS. Okay, so you can expand databases, and this is the part where I restored my the demo data warehouse that we built here, and you can see that it is still a part of a database. All right. So very important concept. And what is databases basically? If you think about it conceptually, what is a database? Right? We all understand from a standard RDBMS perspective that a database is what we understand as a truly relational model. So we all understand ER modeling, we all understand normalization, we have all heard the term OLTP, online transactional processing. I won't be reviewing all these things for you, but I just wanted to highlight a few quick points. So when we talk about a database, we typically tend to relate it to a typical OLTP system, an online transactional processing system. And OLTP is a completely operational system on which your business runs on. Your business runs on OLTP. You have to understand that fundamental concept. Okay, so you think of a typical ticket reservation system, an ordering system. You think of any real-world scenario where you have a warehouse and you have a customer front-end customer system. So it's all an OLTP. It's all OLTP. Everything happens, and that system, that database, and obviously it will have its own interlinked mesh of tables and schemas and columns. But then ultimately, it is built, it is designed to support your day-to-day operations. Very important. So an OLTP system is designed to support your day-to-day operations. ER modeling is the concept that we follow to build a database. So typically when you have to design a database, you typically follow this kind of modeling. ER stands for entity relationship modeling. So what you do is you identify the entities, you identify the relationships between those entities, and that is gradually how you design your database. So the entities that you define become your tables, and the relationships that you define become the relationships between your tables. That's the primary key, foreign key relationships that you establish between your tables, right? So the different kinds of relationships, you have one-to-one relationships, one-to-many relationships, many-to-many relationships, and so on. They are normalized in nature. So almost always they are normalized in nature because, and normalization again is a very deep concept. I won't be getting too deep into it, but at a very high level, and again, it is expected that all of you understand databases at a very high level, but at a very high level, normalization means the level of detail. Okay. So the example that I like to take in normalization, I'll just show you a few things on normalization in a while, but the example I like to take while discussing normalization is where you have one big table and you try to break that table into multiple small chunks. So normalization in short is taking one large table and breaking that large table into multiple chunks. So that is what normalization means in short. Okay, so the idea of normalization is to break that big table and break it into small chunks. Technically, there are a few concepts which I'll talk about later, but just to give you a very high level overview in very simple terms, that's all it means. So break a large table into multiple small chunks. So let's say you have a large, for instance, let's say if you have a very large location table. You have a very large location table which contains, let's say, 50 columns. You has information about country, states, continent, city, pin codes, right down to the the lane where you live. So it has all that information present in one single table. So when you have to normalize that, as part of normalization, what you will do is you will break that location table into multiple smaller tables. You'll break it into one city table, one country table, one continent table, probably one area table, and so on and so forth. So the idea is to break that one large table into multiple smaller chunks. And the whole concept behind doing that is to enable faster inserts, updates, and deletes. So the obvious question that will come to your mind is, why should I normalize it? Why should I normalize it? Why should I break that table into multiple smaller chunks? And the whole reason why you should do that is to enable faster inserts, faster updates, and faster deletes. Okay, and that is really the essence of a truly robust transactional processing system, of a truly robust OLTP system. So because ultimately, if an OLTP system has to support your business operations, if it has to support your day-to-day business needs, it has to enable faster inserts, updates, and deletes, right? Because orders, so customer calls in, customer orders a new product, so an insert will happen, a new customer gets added, inserts happen, customer details get updated, update will happen. A customer calls up the call center and says, what, I don't want to use your product anymore, so that order, I don't want to, I want to cancel my order. So the customers, the customer help desk will go ahead and cancel that order. The delete will happen. So these are all day-to-day operations, right? And the idea of an operational system is to really focus on fast inserts, updates, and deletes. One thing I want to highlight is the objective is not to enable selects. Okay, now I'll talk about selects obviously when I talk about data warehouse. So these are like complete opposites. If you just see the points that I've listed down here, these are all complete opposites. But when I say faster inserts, updates, deletes, it means your focus is on this. Your focus is not on selects. Whenever you think of selects always mean analysis. You want to analyze something, right? When do we write a select statement? You write a select statement when you want to get some information, right? That is when you write a select statement. Think about it. So in a typical operational system, obviously, I won't say selects are not required. Selects are obviously important, and at up to a certain level, selects are important. But then the fundamental objective of using selects is from the context of analytics, is from the context of really digging deep into your data and trying to analyze your data. And this is a related point where I say that normalization is where you're breaking a single chunk into multiple smaller tables, one big table into multiple smaller tables, and because of that you're having faster inserts, updates, and deletes, which is in sync with how an operational system should behave. And because of normalization, because you have divided that one big table into multiple smaller chunks, and all of a sudden your select statements become slower. So you have to understand that more the number of tables, so more normalized it is, more the number of tables, more joins are involved, and if there are more joins involved, obviously the query will take much more time to execute. So it really boils down to more normalized it is, more joins involved, and more time your query takes. So essentially your select statements are slower. Your selects are slower, but your inserts, updates, and deletes are faster. Okay, and I'll show you this as an example how this is the case. I'll just show you as an example, but just keep this in mind. It's a very, very important concept. Another very important concept of OLTP system is that only the current data is stored. There's no historical records are maintained. So at the most, you will have data for the past 1 month or 1 quarter or half a year, or probably at the max 1 year's worth of data. You will not have data which is more than that particular time period. Time period really depends on business requirements, business needs, up to what time frame you want to perform, to what time frame you want to store that data. So the idea is that only current data is stored, which is really what is required from the operational standpoint. For you to run the business, you only need current data. You don't need historical records. Historical records, when are they required? Historical records are required from the standpoints of analytics. Historical records are not required if you want to place a new order, if you want to track whether an order has been delivered, if you want to add a new customer. You don't need to maintain historical records. Historical records are required if you want to ask questions, ask analytical questions like, okay, how are my sales over the past 10 years? All of a sudden, if you ask that kind of a question, your OLTP system cannot give you the answer to that question, because your OLTP system, your normal database, it does not store data over the past 1 year. It has data probably up to a max of 1 month or 1 quarter. So it cannot answer those questions. So that's the reason why I say analytical queries cannot. So just the query that I answered right now, what were the total sales for the northern region over the past 10 years? It cannot answer that question because you don't have that data. There's no historical records that are there. So it cannot, and it should not. So I also highlighted that it should not be executed. And the reason is because as I mentioned that obviously these analytical queries ultimately they're select statements, right? And typically analytical queries can be very complex in nature. They can get very complex in nature, and almost always the more complex your query is, the more number of tables are required to pull your data from. And please understand, if you're trying to run an analytical query from an OLTP system, which is a normalized OLTP system, you have a large number of tables. You have probably hundreds and thousands of tables in your, not really thousands, that's really overstressing, but there are cases, but then hundreds of tables you have. And out of that, if you try to write an analytical query which spans across multiple tables, you have to write a select statement which spans across multiple tables. So when I say spans across, I mean you're writing a select query which essentially performing joins across multiple tables. It does slows things down because it has to perform a lot of joins, and joins are slow. Select statements will be slow, and that's the reason why I say analytical query should not be executed. That's the should not part, and cannot be executed because although if you can, at times if you can, you cannot. But it's like it's more like you don't have the data, so there's no point in executing that query. And obviously, taking a cue from that, reporting should not be done from here. So we understand reporting, SSRS, Excel, Tableau. These are all popular reporting tools for our intent, our course here. We're obviously going to be discussing about SSRS in detail. But then ultimately, whenever you create that chart, whenever you create that table, a bar chart, column chart, line chart, what is happening behind the scenes? Behind the scenes, you're still extracting data, right? So you're still connecting that Excel report, or you're still connecting that SSRS report onto a database, and it is still pulling your data from a database, right? At the front end, you might be displaying it as a bar chart, as a column chart, as a line chart, as a scatter chart, whatever way you might want to. But at the back end, it is still extracting your data. And the fundamental concept that we are driving home here is that if you're extracting data from an OLTP system for reporting needs, it is a big mistake, because again, reporting has a lot of analytics associated with it, because typically management, when they want to see reports, they will always want to see historical trends. Like reports are, obviously there are operational reports where you might want to look at data over the past, let's say 1 year or stuff like that. But then usually your reports are going to serve an analytical need, wherein you're trying to query across multiple tables and fetch information across multiple tables. And if you're trying to do reporting, or reporting as in querying, if you're trying to write analytical queries across large number of tables, as I mentioned, they will be very slow. Your select statements will be slow. Ultimately, the foundation of a reporting is nothing but a select statement. You have to understand this. So whenever I displayed that Excel report yesterday, ultimately what it did was, you had to select. You're ultimately deriving a result set, right? So you're selecting some data sets, some data, and then you're displaying that data. So the foundation is still a select statement. And what I'm trying to drive home here is that select statements are not at all are optimal from a database standpoint, from an OLTP standpoint. Okay, and if select statements are not optimal, if your underlying select statements take a long time to execute because it is a normalized database and there are large number of tables, large number of joins to be performed, if your select statements are slow, then obviously the reports at the front end, when you load those reports, when you run those reports are also going to be very slow. So they should not be done from here, because A, your reports will be slower, and B, that obviously the one reason is that your reports will be slower because your select statements will be slower, and B, the second reason is that if you're trying to run your reports from an OLTP system, you're going to put unnecessary load on your OLTP system. Your OLTP systems are not designed for reporting. Their fundamental purpose is inserts, updates, and deletes. And if you try to load your system for reporting purposes, so next time when a customer tries to place an order, they might have to wait forever. So it's just like a trade-off. So the purpose is not from a reporting standpoint. Coming to a data warehouse, so it's just the exact opposite. So as you can see that it's typically referred to as online analytical processing. OLAP is what we call it. Okay. So the purpose is OLAP. So just like in a database, we follow the approach of ER modeling, which is entity relationship modeling. From a data warehouse standpoint, we follow the dimensional modeling. Okay, so entity relationship modeling is where you identify your entities, which become your tables, and the relationships, which become the relationships between the tables. In a dimensional modeling, you basically have the concept of facts and dimensions. So what you define is you identify your fact tables, you identify your dimension tables, and that is how you build what we call a data warehouse. So it is still a table. So please understand, a data warehouse, as I mentioned, is nothing out of the world. It still lives within an RDBMS. It still lives within a database. It's still a kind of a database. So you still have tables. You don't have like some out of the world structure or anything like that. Only difference is that it is modeled differently. The concept is different. It is modeled differently, and it is denormalized. Okay, unlike a database which is normalized. So in a database, you'll typically want to break that big table into as many small tables as possible to facilitate faster inserts, updates, and deletes. In a data warehouse, it's quite the opposite. In a data warehouse, the approach should be to have that one big structure to keep the tables as denormalized as possible. So going back to a previous example, in an OLTP system, if I have separate tables for city, country, state, continent, and region, if I have separate tables for all these five city, in a denormalized data warehouse, I will typically want to consolidate all those tables into one single big location table. So where I will store my city, country, state, continent, area, everything in that one big table. So that's the whole idea of a data warehouse. Okay. And if you remember that AdventureWorks GW, you had table names which are prefixed by fact and dim. Remember, as I just bring up the SQL Server right now, if you see my databases section, AdventureWorks, and if you see here tables, you can see all these tables are prefixed by dim and fact. Okay, they're all prefixed by dim and fact. Make sense? So, and this is the part where which means that this is my data warehouse. So obviously it's a Microsoft default data warehouse. Someone has already built this, right? But from a conceptual standpoint, if you have been tasked to design a data warehouse, you'll do pretty much the same thing. So the first thing you will do is you go back to the drawing board, you identify what are your fact tables, what are your dimension tables, and then you will gradually design your data warehouse. You identify what are the relationships between those fact tables, what are the relationships between the dimension tables, and how are each of those tables related. Okay, so broadly the relationships part is still the same. So in entity relationship, you identify the entities. Here the only difference, you identify your facts and dimensions. The second part, which is the relationships, are pretty much the same in a database and a data warehouse, because either way they're tables and the tables will be connected. So the tables are not independent. Okay. And this is what is slightly different. If you're coming from a non-BI background, it might be slightly confusing to look at these table names. What is a dim? What is a fact? But that is what it means. This is a dimension table and it's a fact table, and that is how you do dimensional modeling. I'm yet to talk about facts and dimensions. I'll talk about that in a while, but just wanted to get this concept out of the way, what it means. Okay. And obviously, just the opposite. So because it is denormalized, your inserts, updates, and deletes are slower. In a data warehouse, the focus is really on analytics. The focus is not on supporting an operational OLTP system. So an operational OLTP system is from day-to-day business, right? It's for running your business. A data warehouse, the fundamental purpose of a data warehouse is to support analytics. Okay, and when I say analytics, I mean to say it to support complicated select statements. Okay, so obviously your inserts, updates, and deletes are slower because that's not the purpose. In a data warehouse, the purpose is really to store historical data. You're going to dump all your historical data in a data warehouse. Data spanning 10, 15, 30 years, data spanning decades will be stored in a data warehouse. That's the fundamental idea behind building it, so that any kind of trend analysis, any kind of analytics you want to do, you can go back to your data warehouse. You can write complex queries, and you can do a lot of analytics from that data. So that's the fundamental idea. And you never insert. Obviously, you insert data. You do insert data, but then you never update or delete data in a data warehouse. It's not to say it doesn't happen. Almost never do you delete data. We never delete data, but then you do update data. But then again, that happens very, very rarely. Okay, but inserts do happen. Inserts do happen because new data will get added, so that data has to be added to your data warehouse. So inserts will happen, but inserts are slower. It's comparatively very rare compared to an operation system. Operation system inserts happen all the time and in real time. A new order gets placed, new customer gets added, new ticket is booked. So those kind of inserts happen in real time and very, very fast. It has to be very, very fast. The customer cannot be kept waiting. But it's little different from a data warehouse because, as I said, the fundamental purpose is different. The purpose is different, and the purpose here is really analytics. The purpose here is really in a management meeting at 8 o'clock in the morning, monthly 8 o'clock morning meeting, when the management gathers and the management wants to open up a report. Now that report should be able to tell the story of that organization over the past 1 decade. Okay, so it has to have data across the past 10 years, and that report has to run very, very fast. So obviously it is denormalized, and your super fast execution of select statements. As you can see, the less joins are involved. Very important point. Okay, since it is denormalized, the lesser joins involved, and obviously your select statements are much faster. Historical data is stored. There is complete support for all kinds of analytical queries and ideally suited for reporting needs. So these are pretty much the same points where obviously since your selects are faster and since it is denormalized, obviously you have support for all kinds of analytical queries. So and as I mentioned, complex analytical queries, which it turns means complex select statements, almost always use data across multiple tables, right? You will almost always be required to query data across multiple tables, which means multiple levels of joins. And in a denormalized database, data warehouse, that is not the case. So you'll typically have everything in one table, and there are lesser joins required. And also, obviously, it is ideally suited for reporting needs because your reports will run very, very fast. Your reports will run very, very fast because your select statements will run very, very fast because there are very little joins involved. Okay, and obviously there's complete support for queries, analytical queries, because as I mentioned, you have historical data, and it's like a gold mine of data that you have. If you look at this, we've been discussing about this as a database where you're trying to do ETL and you're loading this data into a database. Now, that database is nothing but a data warehouse. That is actually what we call a data warehouse. Okay, from a conceptual standpoint, that is actually a data warehouse. Okay, makes sense? Because that's the whole objective. That's the whole objective of BI, and the central premise to BI, the foundation of BI is really the data warehouse. So what you're doing is, again, to review the concept, you have data across different sources, disparate sources, heterogeneous sources, different formats. You're getting all that data together. You're bringing the data into the company ABC SQL Server data warehouse, and you're finally doing analytics and reporting from your data. Okay, so what do you do? I mean, what is the first step? And just to kind of review the high-level steps again, what is the first step? The first step is obviously that SQL Server data warehouse that company ABC possesses. Someone has to design it, right? Someone has to build that data warehouse. It doesn't just exist, right? And that is really the first step. The first step is modeling. The first step is modeling. The first step is modeling, where you're trying to model your data warehouse. So you're identifying your facts, you're identifying your dimensions, you're identifying what are the relationships between your facts and dimensions. That is the very, very first step that you're performing. That's the modeling step. The next step is where you're performing the ETL. So once you've modeled your data warehouse, that is when you know what are your fact tables, what are your dimension tables, and how they're related. And once you have those identified, you can easily go ahead with your ETL process. Okay, so I just wanted to highlight that the first step really is modeling. And for you to model, you have to identify your fact tables, your dimension tables. And for you to do that, you obviously need to understand what is a fact and what is a dimension. And which leads us to our next discussion, where I wanted to introduce you to the concept of what is a fact table, what is a dimension table, and what do these terms mean in the first place. Now I'm going to give you a much more holistic understanding of what is ETL? You're extracting data from source, you're doing some transformation on that data, and finally you're loading the data onto a data warehouse or a database, whatever. I mean, that destination can be anything, that source can be anything. So if you have to look at ETL from a very classical standpoint, from a terminology, very, very literally standpoint, what ETL means is the source can be anything, the destination can be anything. You probably get more clarity when I get into the hands-on aspect of things, but from a very classical BI standpoint, the course that we are discussing right now, from a very classical BI standpoint, ETL typically refers to when you're taking data from OLTP systems, you're doing some transformation and you're loading data into a data warehouse. That is from a very classical BI standpoint. So you have data sitting in OLTP systems, you're bringing all that data in, you're doing some transformation, and you're loading that data into a data warehouse. That is what ETL means. And to answer your question, can it be performed on a database? Absolutely yes. Can it be performed from a data warehouse? Absolutely yes. So you can absolutely have a scenario. You can absolutely have a scenario where, let's say, just to quickly go back to my diagram again. You can absolutely have a scenario where these, as I mentioned, these are the Excel files, the flat files, the databases, SQL Server database, Oracle database, DB2 database. This can be a data warehouse also. This can be a data warehouse also. This can be a database also. So the source can be anything. The destination can be anything. So, but from the classical BI standpoint, as I mentioned, typically what we are trying to achieve is we are trying to load all our data into a data warehouse. So our source is typically operational systems and our destination is a data warehouse. That's from a very classical BI standpoint. All right, awesome. All right, so what is a fact? How to think of it, and the example I like to take here is, again, what I've done here is I've established a connection with a basically established right. So I have established a connection with AdventureWorks. So this is the AdventureWorks database, and as you can see, I brought in these fact tables or dimension tables. These are the set of tables I have. So what I've done here is I've just a simple pivot table. So what it's showing you is the sum of sales amount, right? This is sum of sales amount that you're seeing right now. Okay. So what does this mean? And just to give you the context, this means that so what I've taken the product category, the product subcategory, and the sum of sales. So what is the total sales you're making across all your products, all your categories, all your subcategories, and so on. So that's the data that's what the data means here. So simple pivot table, right? You can drag and drop your categories. You can drag and drop. Let's say if you have a product category here, you can maybe have a product category name in rows, and what it will do is it will basically slice it by rows, and now you can see what has been the total sales across different categories. Okay, yeah, so you might want to remove this, and you might want to look at it for individual colors. Let's see what we're to look at for individual subcategories, and now you're looking at sales across different subcategories. Right, makes sense. So this is what the data means. This add some context to the data. And what does this mean? When I don't have anything to slice by, this gives the aggregate value. This gives the total sales across all categories, all subcategories, and all products. Okay, this is the total sales, right? So keep that in mind. Now, this number means nothing. So first things first, just wanted to introduce you to the Excel concept here. First things first, what is a fact? Fact is anything that is a number. So from the BI context, facts and measures are one and the same thing. So sometimes you will hear people say facts, sometimes you will hear people say measures. So facts and measures mean one and the same thing. Okay, something that I've listed out here. Okay, so anything that is a number that can be aggregated, summarized, is a fact. And what do I mean by aggregated or summarized? I'm already, when you say aggregated or summarized, it means you can perform any kind of mathematical operation on that. Right, so typically you can group by a particular attribute, and you can perform some kind of mathematical operation, be it a sum, an average, a min, any kind of aggregate operation. You can aggregate that data. You can sum that data, you can average that data, min that data, maximum that data, standard deviation of that data, variation of that data, variance of that data, and so on and so forth. Okay, so in short, facts or measures are any numbers which can be aggregated or summarized. Examples as I've highlighted here: sales amount, tax amount, number of calls, number of defects. So if I give you, let's say, 5 values of sales, if I give you 5 sales amount values, and if I ask you to find out what is the total, you can simply add them up and you can say this is my total sales. So it can be aggregated. If I tell you the total number of defects for 5 people, let's say a number of defects for 5 people, and if I ask you what are the total number of defects across the team, it's very easy to sum up those 5 numbers and tell me, okay, this is the total number of defects. So you can aggregate, you can summarize that value. Contrary to that, not all numbers are facts. Very important concept. Not all numbers are facts. And what am I trying to say here? For instance, take the example of a phone number or a zip code. If I tell you the zip code is 5678886, let's say these are the zip codes for 5 people. Okay, these are the zip codes for 5 people. And if I ask you what is the total zip code, it just makes no sense, right? If I give you 5 zip codes here, and if I ask you what is the total zip code, you can't just add up these 5 numbers and say, okay, the total zip code is 2843900, right? So although zip code is a number, that number is not a fact. Okay, so not necessarily all numbers are facts. It is only those numbers that can be aggregated or summarized, and if those aggregates or summaries have meanings, implicit meanings in them. In this case, although zip code is a number, if I give you 5 zip codes, if you add up those 5 zip codes, total zip code, it has no implicit meaning. It makes no sense. Same for phone numbers also. Phone numbers can also be numbers, right? They are also stored as numbers. Now you might argue that no, they're not numbers, they're characters. You can have plus whatever plus country code. Agreed. But in case, let's say, for some reason, let's say you're storing that as a number, you're taking that data from an underlying database where it is stored as a number, and you're confused what to do. Is it a fact? It is not a fact, because you can't add up 5 phone numbers and say it's my total phone number. Makes no sense, right? You can't take the average of phone numbers, right? So all numbers are not facts or measures. What are dimensions? Dimensions are things which add context to your measures, and this is the important part. Okay, so facts are the numbers, they are the aggregate numbers. So as you can see, sales amount here, just coming back to our example here, sales amount, this is the fact. Okay, this is a fact, sales amount, right? But this is one big number. Think about it. This is one big number. This is like the total sales across all your products, all your product categories, subcategory products, everything. It's one big number. It doesn't tell you anything. It doesn't give you any information about how your company is performing. This is where you need dimensions. And this is exactly where dimensions can really add context to your facts. And that's why I gave the definition where I'm saying dimensions are things which add context or detail to your facts. So if you want to dig deep into your data, if you want to really ask questions about, okay, how is my total sales, how is my sales performing across different product categories, different product subcategories, if you want to dig deep into that, that is where your dimensions are handy. So what am I trying to say? So you can actually go back and take a subcategory, just as I did right now. You can drag and drop your category here, and now you can see that I've all of a sudden broken that. So this was the initial number that I had. Just remove that. You can see this is 2935867. If you just go back and if you take your subcategories, you will still see the same number, 2935867. So the total is this. But what you've managed to do is you've managed to slice this data into multiples. So this product subcategory name is now a dimension for me, because it is using this that I've been able to add context to my facts, to add detail to my fact. Okay, this was my fact. Remember, this was my initial fact, but now using my dimension, I have managed to slice it across this. Okay, just think of it like an x-axis. Think of it like an x-axis. Not sure how to make you visualize, but just think about it. Just try to visualize it, just like your x-axis. So this was one big number, and what you've managed to do is you've managed to break that number into multiple smaller chunks across this dimension of x-axis. Make sense? Same way you can take, let's say something like a product name. Same way you can take something like let's say a product category. Take it in columns, and now you've managed to split that further into further level of detail. You can see this. You still have the one big number, 2935867. That's the initial number you started off with. But now you've managed to not only break it across rows, but now you've also managed to break it across columns. Very interesting. Very, very interesting the way you can do it. Okay, so that's where the definition of dimensions come from. Dimensions add detail to your facts. Dimensions add detail. They add context. Facts in itself mean nothing. If I just tell you total sales, total tax, total number of defects, they mean nothing. It is only when you add detail that you get to really analyze your data, and that's where dimensions become very, very helpful. So dimensions are almost always categorical data. From a very data classification standpoint, we call dimensions categorical data, whereas facts are numerical data. Okay, numerical data, as I mentioned, are numbers which can be aggregated, summarized, and the aggregates have some implicit meaning. But categorical data are most of the time, probably 99% of the time, they're textual data. So there's some kind of categorical data, they're textual data, varchar types. Okay, you might want to add more categories here, colors. You might want to analyze based on colors, and I can see the level of detail that you can add here. It's just incredible what all you can do. And now you can see I've added in colors here. It's just breaking it down even further for each of the subcategories. You want to analyze in more level of detail. Let's say you might want to add product name. You can actually do that as well. Come down, add again product name. Don't get confused. I'm just giving an example. So it's not to mean that you have to know exactly how to do it in Excel. Excel is just an example reporting tool I'm taking. Obviously, the same thing that you're doing here, you can perform in any other reporting tool. But I just wanted to give Excel as an example because it's easy to follow. Right? I hope this concept is clear to all of you. Yeah. So I'm going to go ahead and remove it, and now I'll come back to our initial value of 2935867. All right. So these are all examples of dimensions, and just as I mentioned some time back, zip code can actually be an example of a dimension. So you can actually call it a dimension, okay? Because you might want to look at things like, let's say I give you the total sales amount here, the total sales amount, and now you want to analyze your sales amount by each zip code. So what you might want to do is you might want to group by zip code across the rows, or group by zip codes across the columns, and you want to split that one big sales amount number across zip codes, and in which case zip code becomes your dimension. It might be phone numbers also, so you might want to look at number of calls. As I mentioned, number of calls can be a fact, right? So you might want to look at total number of calls, but then you might want to split that across different phone numbers, in which case phone numbers become a dimension, right? Make sense? Hope this is clear to all of you. All right. So moving on, and that's about facts and dimensions. And the other terminology aspect I wanted to cover here is that when you talk about facts, the columns in facts are what we call, as I mentioned, they are facts, they're measures, right? And in dimensions, they're basically called attributes. Okay, just to come back to our, just quickly open up my SQL Server here. All right. So the other thing that I wanted to touch upon is something that I've already talked about. Why is denormalization? Why am I really saying that denormalization select statements are faster and in normalization select statements are slower? Why am I saying that? And this is where I wanted to highlight a very good example that I built here, where taking a very simple case. If you just take a quick minute to go over it. Just give you guys a quick minute to go over it. So the context really is that you have a sales table, invoice ID, sales and country. That's the context. And so in one case, you can see that the country, this is a denormalized setup. So what you're seeing here is a denormalized setup where you have the sales and the country information available in the same table. But here you have a normalized setup. This is a normalized setup because here you have it available in two different tables. So you have country ID and the name available in a different table, right? So you've broken this up in a separate country table. So this is normalized, this is denormalized. And you can see that the question that I'm asking really is, what was the total sales for USA? And just I want you guys to take a minute to think about it. So if I ask this question, what was the total sales for USA? The kind of response you will get if you're trying to run this query in a normalized table versus a denormalized table, you can just imagine the speed at which the queries will run, the difference in the time that will be taken. So take a couple of minutes to go over it. So I've given two options. These are two corresponding queries you can run. Right. One is obviously the having clause you can use, and the other is a simple where clause you can use. So essentially, they will give the same result. But what I'm trying to highlight here is that in the first option, in the first case where the tables are normalized, you can see that an implicit join is required. You have to perform a join, and that join is essentially going to take time. That's going to slow down your query. Okay. Unlike that, in the second example, you can see the join is not required. So you can directly query it from a single table because you just have one table, and you can simply say where country equal to USA. Okay. So no joins are required, and your query will be much faster. And this is where I really, and this is the reason why I say that in denormalized setup, your select statements are much faster, and in normalized OLTP systems, your select statements are slower. That's really the root of the what we're discussing here. I'll give you guys a couple of minutes to go over this. In the meantime, I'll take a quick couple of minutes pause also to spend some time on it. Hey guys, welcome back. All right, so hope this is clear to all of you. Hope you got an opportunity to go through this query, and I hope this is clear to all of you. Again, to reiterate and just to reiterate the concept once again, this is a normalized setup where you have you essentially have two tables. You have the sales in one table, you have the country information in the other table. And if I want to know the answer to this question, what is the total sales for USA, I have to query both the tables, right? I have to join both the tables because I have to filter by USA. Okay, and unlike that, if I have a denormalized setup where I have the entire information stored in one table, you will see that I don't really have to do this. I can simply go ahead and just query the data from one table. So less joins, and essentially the query will be faster. Okay, now I have one more sheet where I've given an example. In the meantime, I was just preparing this for you, where I just wanted to explain to you the concept where, what really happens if in a normalized setup. And I mentioned this point before, where I say that in a normalized setup, you see that the inserts, updates, and deletes are faster. And some of you had questions why this happens. Why are inserts faster? Think about it this way. Why are updates faster? And just to highlight that, I've taken an example again. The location, this is a location table where you have ID, location ID, the city and the country. Okay, and obviously you have the city table and the country table. Right now, what you really have to do here is to think of it from the scenario where, let's say, so obviously what I'm trying to highlight here is just a location table. That's a denormalized setup. So probably you can just give a different color here, represent that with a different color. And these are the normalized. These are normalized setup, right? So just have it as a separate group. So there's the different groupings that I have. Okay, so that's your normalized, that's your denormalized table where you have the city and country information present in a single table. And this is the normalized setup where you have the city and country information present in two different tables. So this is the city and the country is present in a separate table, and obviously they're grouped separately. Okay, so now what I'm trying to highlight here is again the concept why in a normalized setup updates are faster. So think about a scenario where all of a sudden what happens is um, USA, let's say India, all of a sudden India decides to change its name to IND. So it's decided that India is now going to be called IND. So you decide to use the abbreviations from a very business standpoint. As a business rule, you're saying now we'll no longer call it India, we're going to call it IND. So you have just 4 rows here, but just to give an example, you have just 4 rows, but you can have literally millions of rows in this particular table. So what you have to do is you have to go to each one of the rows and you have to update India to IND, right? You have to go to each one of the rows and you have to update India to IND. This is what you have to do, right? Think about it. Think about it from a logistical standpoint. It's a nightmare. It's a nightmare. You have to write literally, I mean, how many updates is going to be performed? You can think about it, right? You can think of like a million updates are going to be performed. If there are a million places where India is occurring, then you have to update in million places, right? That is not good. That's not good practice. Compare that with a scenario. That's what happens in a denormalized setup, and that's why I say in a denormalized setup, your updates are slower, right? So your updates are slower because you have to update in multiple places. In a normalized setup, however, if the same thing had to happen in a normalized setup, you can see that now is the same India. It's the same India, which is 1, but now it is no longer India here. It is referred by 1. So all you have to do is you just go here and you update in one place, and wherever the ones are coming, it will automatically map to India. Right? So you can immediately spot why I say that inserts, updates, and deletes are faster. I'm taking an example of insert, but updates and deletes work pretty much the same way. Okay, so they work pretty much the same way. So in this case, you have to initially go to each row, you have to delete it, but here you can simply delete that main parent. If you delete that main parent, it will automatically remove the references. Okay, so what I'm trying to highlight here again is that in a normalized setup, your updates are faster. Very, very fast because you just have to update in one place, unlike updating in every single place here. Makes sense? Again, if you say, okay, it's kind of going to India, so you have to update in 3 places compared to just a single place here. Just come here, update it, and everything that refers to this by the key column will be updated automatically. Makes sense? So that's one of the reasons why I say inserts, updates, and deletes are faster for a normalized OLTP system. I did mention the concept of transformation, and I wanted to show you a quick example what it means. And it's a pretty simple example. I've already talked about it, but I just wanted to give you, to show you, just to give you a flavor of what transformation means. So what I have here is, and when I say transformation, again, it just borrows from the concept of an ETL. So E stands for the extract, T stands for the transform, and L stands for the load. So you're extracting data from the source, you're transforming the data, and finally you're loading the data onto the destination, right? So that's the basic concept that we're talking about here. So you have source A. So this is like, let's say your retail outlet 1. Let's say just storing data, ID and gender. Okay, source B, again, you have a simple table ID and gender. So these are the 2 sources, and the objective really is to take these 2 sources and load these 2 sources, consolidate data from these 2 sources into a destination, and let's say destination data warehouse. So you can think of it like retail outlet 1. You can probably add a sales column here. Some other information also is there. So you're tracking sales by gender. for each transaction that you're maintaining. So, but what I want to highlight here is that source A, that is retail outlet 1, it is storing data, gender data as male and female. Retail outlet 2 is storing gender data as M and F. So the conventions that they're using, the business rules that they're using are different across different sources. Okay, and this is really a fundamental premise behind doing transformation and what I call data cleansing. Okay, so you can see that the conventions are different. You can probably have another source C, which is probably storing male gender information as binary. So probably they're saying male is a 0, female is a 1, and that is understood in their line of business. So their line managers will understand that terminology, but other people may not understand it. Probably there's a source D, which is storing gender information as a picture. Let's say they're using icons. So male icon, that's like a male symbol for males, female symbols for female and stuff like that. And maybe there's some source E which is using something else. I mean, some other characters, for referring to male genders and female genders. So what I'm trying to highlight is data warehouse, and there's one of the other concepts I wanted to mention. Data warehouse is really the single version of truth. So when you consolidate all your source data, data across disparate sources into your data warehouse, that data warehouse becomes your single version of truth. It gives you a 360-degree view of the organization, and that is your single version of truth. And when you design a data warehouse, as an architect, you have to define what that truth is. So now there are multiple versions of truth. So one person can say, okay, male is a gender, but is male the same as M? Is M the same as a 0? Is 0 the same as that icon? So are they one and the same thing? Who decides that? That is what you have to decide. That is what, as an architect, you have to decide which ones are the same, which ones mean the same, and how you're going to store the data in the data warehouse finally. So when you finally create a gender table in your data warehouse, how will you store the data? Will you store it as MALE male, or will you store it as capital M, or will you store it as a 0 binary? So that is a call you have to take. So that's what I have to say. Set of rules that you have to define. So gender will be either M or F. So that's a rule that you have to define. And based on that rule, next time when you try to do that ETL, next time when you try to load that data, you're trying to extract your data, and this is the stage where you're performing the transformation. Here, you're going to perform that conversion. So let's say if you decide that I want to maintain everything as M and F in my data warehouse. So now what you have to do is, in that transformation stage, you have to transform, you have to replace, or let's say you have to replace all males with M and all females with F. So you have to convert males to M and females to F. So when you're taking data from this source, you have to perform that conversion. Obviously, if you're taking data from this source, there is no conversion to be performed because they're already in the right format. But when you're transferring this data to the data warehouse, when you're transferring source A's data to the data warehouse, and in this phase, you have to convert the males to M and the females to F, and only then will you be able to load it, because this is where you define the business rule that, boss, my genders can either be M or F. I won't allow any binaries. I won't allow MALE or FEMA. I won't allow any pictures. They will either be M or F, and that is where the transformation logic comes in. Another example can also be in the terms of phone numbers I mentioned. So probably, let's say you have another column here which has country code included, mobile numbers including country code. Let's say you have a column here which consists of mobile numbers including country code, and let's say the logic that you define in the data warehouse, that I don't want any country codes, I don't want any special characters like plus or hyphens occurring, I just want the number as it is. Okay, so then what you have to do is, in that transformation layer, you have to remove all those characters, and then you can load data into the data warehouse. So you have to define a set of rules. It again happens in the modeling phase, where you not only identify your facts and dimensions, but you also identify these business rules, and it is based on those rules that you perform the ETL. So modeling becomes a very, very important stage in that respect. All right, hope this is clear to all of you. Hope the concept is clear to all of you. All right, moving on. All right, moving on. There is one other thing that I really wanted to talk about, and probably the final thing I wanted to cover here is to concept of schemas and a little bit about modeling, how you do modeling. Now, please understand this is not a modeling course, and it's by no means estimates a modeling course. Data warehouse modeling is a completely different monster, and there's so many related concepts associated with it. But it's by no means a modeling course. But I still wanted to give you guys a flavor. I want you guys to understand how modeling is done because it's an important concept. Okay, and as I mentioned, MSBI, most of you are developers. So when you get into projects, the idea is that someone would have already modeled the data warehouse for you. Someone would have already done that modeling. Someone would have already built the data warehouse for you. So all you have to do is you have to build a logic to transfer data to the data warehouse. So most of you, what we will be doing probably is that you're going to be taking data from the source. You're going to be writing your logic. You'll be developing ETL packages, and almost always you're going to be loading the data into the data warehouse. But you may not get the opportunity to model the data warehouse. So modeling is a pretty advanced domain, which usually is done by business analysts, right? So we have already discussed quite a lot about the concept where you identify facts, you identify dimensions. We already talked about it. Facts are the numbers, dimensions are things that add context. So one of the first steps that you really do is talk to your clients, understand their needs, understand their requirements, and based on that you decide, okay, so these are going to be my fact tables, these are going to be my dimension tables. This is how, and this is how my facts and dimensions are going to be related, right? So that is what you do in the modeling phase, and there are basically two kinds of schemas that you have really. So when I say modeling, ultimately what you're doing is you're trying to develop a schema, right? So when it comes to a data warehouse, there are broadly two kinds of schemas that are really popular. So one is a star schema and the other is a snowflake schema, right? So I'll come to the differences in a while, what the star schema and snowflake schema means, and until that time I want to keep the discussion a little more generic, and I want to talk a little bit about what really happens. I mean, what are we even talking about? How are the facts and dimensions even related? And to discuss that, let me take the example here. Let me quickly come here and let me take the example here. And what I'm going to do here is I'm going to quickly open up a different kind of wizard just to show you the relationships. Unfortunately, my database diagrams here is not functioning. Let me quickly check if, let me see if I can get the diagram up for you. All right, so I'm going to do this slightly differently. I just want to give you a pictorial representation of how the tables are related. Just opening up all right, so what we have here, and don't worry too much about what I'm sharing with you. So basically what I've opened here is the analysis services data source view, but I don't want you to get confused about what is analysis service and other things at this moment. So I just wanted to get this diagram up for you. Unfortunately, my diagram organizer is not working there, so I just wanted to bring it up in AS and just show you how the tables are related. So what I have here is basically just to simplify the things a bit here. Let me just take the fact internet sales, and let me just take the product category and product subcategory tables, the kind of tables that you're already interactive with and you're already comfortable with. So click on OK, and as you can see that, right. So as you can see here, that's my fact table. That's my fact table. And I'm going to quickly go ahead and remove these other tables also. All right. So simple example where I have my fact table, and just to expand this a little bit, you can see the structure of the fact table, columns it contains, and you can see there's my dimension table. So fact tables are always prefixed by fact, dimension tables are always prefixed by dim, something that we've already talked about. And we have talked about dimensions, we have talked about facts, and I'm just showing a diagrammatic representation. It's exactly the same as what you will find in SQL Server also. There's no difference. So this is what you will define at the very first stage of the modeling phase. So you have to define your fact tables, and you have to define what all columns will get into your fact tables and the dimension tables, right? So in short, dimension tables contain the primary key. So if you look at the dimension of dim product, so first thing, obviously, you're going to have the primary key of a product key, and all the other columns are going to be attributes to the dimension. So we call them attributes. So the first column is the primary key. which we all understand is the column that uniquely identifies each row in the table, and all the other columns are going to be attributes to that dimension. So if you look at dim product, the first the product key obviously is the primary key, and all the other columns are going to be attributes of that particular dimension. So think of something like, as we were discussing in the Excel example that I showed you, we had color, we had English product name, we were comparing by size. So all those are attributes of that dimension. So the obvious question is, how do I group them into one particular dimension table? Well, that is the call that you have to take. So if you have identified a list of 3 attributes, in our case, we had identified English product name, we identified color, we identified size, we identified class. So all those are apparently part of one single grouping and as part of the product grouping, and hence they all become part of the product dimension. As you can see that these are all part of the products. These are all attributes of a product. Okay, and these are all dimensions. So you might so the same way that we used the same way that we used product name or color to add context to my fact, that one big chunk number that I had, the same way I could have used any of these other values also. I could have used weight, I could have used dealer price, I could have used class. It's another matter that what you use to classify depends. So in other words, although English description is an attribute, but you may not use English description to group. You may not use English descriptions to group your data. In other words, you will not do something like total sales amount by English description. Makes no sense, right? But it is still an attribute of a product. So in short, in a dimension table, you will identify your primary keys. What is the key that that really makes that row unique? And the second thing is you have to identify all the attributes to the dimension. It's the same way that you do in a table. This is very similar to that you do in a table. Next, coming to a fact, what are you identifying a fact? In a fact, there is no concept of primary key. Sometimes they are, sometimes there aren't. Most of the cases, you don't have primary keys for fact tables, but you do have the concept where you have facts. You can see these are all the facts that I have. Discount amount, standard cost, total product cost, sales amount, tax amount. So you group up all the possible measures that you might identify. Okay, so first of all, obviously you will talk to your customers, you understand the business, and you figure out, okay, these are the things that you can measure. These are the things that you want to analyze. And the question really starts with the end in mind. So when you do the modeling, you have to start with the end in mind. And what is the end? The end is where you are visualizing what kind of things the customer wants to measure. In other words, what kind of things the customer wants to see. Because you design the data warehouse from the reporting needs in mind. So it's almost always the case. Because the ultimate objective is to see your data, right? You might have done an exceptional job in storing your data in a data warehouse. You might have done some exceptional job writing an ETL, developing an ETL package, but none of that makes sense if you're not able to visualize your data, even if you're not able to communicate your findings to the end users. And which is where I really highlight and reiterate the point that you design a data warehouse thinking about your reporting needs in mind, really keeping your reporting needs in mind and stressing on your reporting. So as an architect, you will talk to your customers, you will understand what is it that they want to see as the final objective. What is it that they want to see? That is the question that you have to ask. Okay, so if the customer wants to see what has a total sales, analyze their total sales by each gender, by each category, by each region. In that case, you clearly know that sales is your fact. Sales is something that you have to capture. Okay, and then it's a very broad discussion, and the moment you understand that that's a thing that you have to capture, so automatically that goes into data collection, data capture. So it's not really in the scope of our course, but what I'm saying is in the modeling phase, you do all these steps. You not only identify what your facts are. In this case, sales is a fact. Now customer says I want to analyze based on gender, so gender is a dimension. They want to analyze based on products, product is a dimension, right? So and once you identify that, next thing is you have to go back and question, can I get that data? Which is also a very, very important question. Customer might say, all right, so get me the number of defects by each person. Customer might want to know that data, but it might so happen that you don't have any defect tracking in the project. You may not have the data, right? So it's one thing to say that, I want to see this, but if you don't have the data, you can't see it, right? And most of the times what happens is it is only after you embark on a data warehousing project that you decide that you figure out your requirements, that you figure out, okay, this is what I want to achieve, and then you put in place data collection techniques to make it happen, right? And that's all that facts are. Facts are things, these are metrics, these are hard metrics that you want to crack. In short, to identify your facts, identify your dimensions, build your fact tables, build your dimension tables, right? Coming back to a discussion, and here, so what you have here are a group of those facts, and then all you have are the foreign keys. So in the dimension table, you have the primary key. So this is one dimension table, and if I have to quickly go ahead and add all the other dimension tables also, just to clarify the concept. And here all of a sudden you can see there's the fact table in the middle. That's your fact table. So you can see each of these are dimension tables. So you can see this is dim product with the product key. This is dim customer with the customer key. This is dim date with the date key. These are all primary keys. These are all dimension tables with the primary keys. Currency with the currency key. This is the primary key. These are rest all attributes. Promotion with the promotion key. Primary key, rest all attributes. And finally sales territory with the sales territory key. Rest all attributes. And finally, to wrap it up, you have the fact internet sales with the fact table, where obviously it is linked to each of the primary keys through foreign keys, and you can see product key, customer key, promotion key, currency key, sales territory key. These are all the foreign keys that you have. Okay, you might be confused that why is there not a date key? Now it's a slightly more advanced discussion. I don't want to get into it, but then there's a concept of a role-playing dimension. I'll talk about it later. But instead of having a single date key here to represent your, so essentially you have order date key, due date key, and ship date key. That's what you have. You have three foreign keys that are linked to this particular primary key. Okay, so that's a concept of role-playing dimensions that you have. So but barring that, taking the keeping that aside, let me go back and remove it in case it's get a little confusing here. So let me leave that aside. The others you can understand that for each primary key combination you have a foreign key pair here. And if you take a list of that of all the foreign keys, that is what determines the uniqueness of a row, which is what we call a composite primary key. So the composite primary key for the fact table is mostly the combination of all your foreign keys, which will determine that each row is unique. All right. So that's how you define a fact table. Coming back to our discussion of a schema, and just what we were talking about before we headed off to talk a little bit about these fact tables and dimension tables. I wanted to show you. I wanted to just show this to you so that you have clarity. Again, it's just very initial days of our discussion where we haven't really spoken a lot about, haven't really gone into the practical aspect of things, the demo aspect of things. But I still wanted to get this out and clarify the fundamental concepts for you. Go ahead and close this. Coming back to our discussion of the schemas, and you can see that star schema is where it is a typical denormalized form, right? So all that we have been talking about so far, from the concept of from a data warehouse where things are denormalized. So star schema is where you have one big fact table sitting in the middle. So just visualize it. Just visualize a star schema where you have one big fact table sitting in the middle, and you have all dimension tables surrounding it. That is what a star schema is. And if I have to quickly go back to our example again, I'm sorry I closed this, and just to quickly bring this up. I'm going to quickly bring this up. It's an excellent example where I could have displayed a star schema for you. I come back to, this is a typical example of a star schema. Excellent example of a star schema, where you can see that I have one big fact table in the middle. You can see there's a fact table in the middle, and it's connected to all the dimension tables using a single level of join. Very important concept. So the fact table is in the middle, and it is connected to all the dimension tables using a single level of join. Why is it called a star schema? Because you can see it resembles a star. Okay, so you have one. It's just like the hub and spoke model. You have one hub in the middle, and all the spokes are around it. So and very important is that the fact table which sits in the middle is connected to all the dimension tables to a single level of join. Very important concept. And why do I stress that? Why do I stress that? And this is what really means when I say denormalized. This is denormalized. Okay, this is denormalized. You might still be questioning, okay, how is it denormalized? I still have a single level of join, but that's what it is. That's what you have to have, right? That's the basic level. You got to have that. A single level of join is something you have to have that. So fact table connected to all the dimension tables using a single level of join, primary key, foreign key. Okay. Now, example I like to take here is product, and you can see product is further linked to subcategory key and category. So if I go to my add remove, and if I add in two extra additional layers for product, I go ahead and add in my category and subcategory. Now it becomes what I call a snowflake schema. Very, very important. So let me come back and remove the state. It's not really adding any value. Let me go back and adding some more space to it. Go back and arrange tables. And now you can see that. Now you can see that's my product, that's my subcategory, and that's my category. Again, it is just like come back to Zoom. Let me go to 2fit just to show you the structure, and you can see that again. It's just like a star. Just like the star that we were seeing before, you still have the fact table, and it's linked to all the dimension tables to a single level of join. You can see fact is linked to dim customer through a single level of join. It's linked to dim promotion through a single level of join. It's linked to dim sales territory through a single level. Same for dim customer through a single level of join, and same for dim product through a single level of join. But then it's snowflakes here. Moment you think about fact internet sales and dim product subcategory, they are not directly related. So this and this are not directly linked. They are linked through another dimension table. And you can see that between this and between this, there are two levels of join. There's not a single level of join. And this is what we call a snowflake schema. Same for product category also. You can think of product category and the central fact table. They're not really linked directly. They're connected through transient relationships. Okay. So that's what we call a snowflake schema. And as you can understand, compared to the first case, this is more normalized in nature. It's a more normalized because you have more number of tables, right? Make sense? Coming back to our discussion here, so snowflake schemas are more normalized, so more joins for data retrieval, and obviously queries will take more time. Unlike that, star schemas are more denormalized, there are lesser joins and queries take lesser time. All right, I have a pretty similar example explained here also, but I hope you got the picture. I hope you guys got the picture. So just to reiterate this final example that I have here. So all I have is the fact table that I have here with gender ID, date key, and city key, and sales amounts. So in a typical star schema model, you can see the gender ID linked to gender with a single level of join. Date key obviously linked to date key here, and finally city key is linked to the city key here. Right. So that's my typical star schema. If you think about this part, whatever I'm highlighting right now, so just exclude the upper part here. So whatever I've highlighted here, that's my star schema. Okay, you have the fact table in the middle, and it's connected to each of the dimension tables, gender, date, and region, using a single level of join. Make sense? So if I ask a question, what is my sales for USA? It's a very simple query to answer. It is denormalized in nature, and I will immediately get the answer to my question. It's very similar to the example I showed you before. Compared to that, how can you normalize it? So it's the same example I showed you before. Instead of having region as one table, you can have city and country as two separate tables. Now all of a sudden, it's the same thing. Gender is still a single level, date is still a single level, but then all of a sudden city is one level, but country is two levels. You can see to reach out to country is a snowflake. So city to city and this to country. So you can see the two levels. So now this becomes a snowflake schema. All right, so that's it. That's about star schemas and snowflake schemas, and that pretty much wraps up our introductory discussion that I wanted to have with you guys at this moment. So we have discussed about the high-level aspects of BI. We understand MSBI. We understand the different components of MSBI, SSIS, SSAS, SSRS. Obviously, I have a very, very in-depth discussion about databases, data warehouses, OLTP, OLAP, star schema, snowflake schema, facts, dimensions, how is a typical data warehouse modeled, and at a basic level, we discussed. I showed you a few concepts on normalization and denormalization also. Okay, so hope you guys got value.
Just a quick info, guys. Intellipaat does provide end-to-end training on MSBI. So if you are interested, you can check out the course details given in the description below. So this brings us to the end of this session. If you have any queries, you can leave a comment down below and we'll reach out to you immediately. Thank you for watching, guys.